Okay, so this is our transmitting circuit. The first thing in our circuit is a virtual ground, which is these two resistors that are the same, and this op amp. So we use this so we could get a plus 9 volt terminal, a negative 9 volt terminal, and a ground. So this is the mic, and from the mic we have 5 volts, which we got by using the potentiometer and the 9 volt battery to get exactly 5 volts into the microphone. And the microphone goes through an op amp here with a feedback resistor of 100 ohms to amplify the small output from the microphone. The music starts down here and it goes through a capacitor, and then up here it mixes with the mic output. Then it goes through another op amp up here, which has a feedback resistor of 1.1 mega ohms, so we can get a really big gain. And then here's a capacitor, an inductor, a resistor, and our bias T to protect the AC voltage and the DC voltage from each other, and then it goes out through the laser.
Okay, so first there's a solar cell that the laser transmits voltage into, and it then goes into a high-pass, low-pass filter, which is made of capacitors and resistors to pass signals with a frequency both lower and higher than the cutoff frequency. There's capacitors to try and filter out the DC signal and make sure AC signal ends up going into the speaker. And input into the first terminal of the potentiometer is the 9 volt battery, and the potentiometer is used to create a virtual ground with the battery. Okay, so the output from the potentiometer goes into the op amp to amplify the signal. The voltage in and out of the op amp comes from the battery, and we use a 10 kilo ohm resistor for the feedback resistor to create some gain. The capacitors here are put in parallel to be added together to have a large enough capacitance to try and filter out some of the DC signal and get rid of some of the static. And it's then connected to a speaker that outputs the mixed signals of the music and the microphone. And here's the full circuit. Okay, so now we're going to talk about some of our problems and improvements that we used for our circuit. One of our problems was we first used a photodiode to detect the signal from the laser, and then instead we used a solar cell, which is a lot bigger, so it's easier to see from 50 feet away. And then also our signal from our speaker was really staticky, so we just kept trying to add capacitors in parallel. We now have 3 capacitors. At first we only had 1 to try and stop the static from coming out of the speaker.
Another issue we had was we needed a plus 9 volt terminal, a negative 9 volt terminal, and a ground so that we could charge the op amp in our circuit. So originally we were using 2 batteries to do this, but 2 batteries for just the transmitting circuit, but we only had 2 batteries total, so we had to figure out how to make a virtual ground using just the 1 battery and the voltage divider. And then our last issue was we had a lot of trouble with the equipment. The audio jacks that we were putting together kept falling apart because they were so fragile. So we went through a couple of different wires on those. So another problem we had was with the speakers. The ones that they gave us broke really easily. And so we switched to a computer speaker like this, which is bigger and sturdier, so it didn't break as often. Now we'll show you our speaker working from a close distance and from 25 feet away.
Okay, so then I'll cut to that.
Okay, this is a video of our circuit working and playing music, which you can hear through the speaker. The distance we did is about 25 feet away, which was what was required in our project. You can see the laser being shot at the solar cell. When it was 25 feet away, it was hard to keep the laser on the solar cell because it was such a long distance to shoot the laser.